Good evening, everybody, and welcome to yet another vBrownbag US. Tonight, we are going to continue on with our 2-month-long study in the AWS Solutions Architect Certification Study Plan for all of those of you out there that are wanting to sit and pass the AWS SA Associate Examination. This evening, we're going to be going over Domain 2, Implement and Deploy. We have with us the illustrious and impeccably dressed Bryan Krausen of AHEAD. Couple of housekeeping notes before we get started. Get in on the conversation. I will be monitoring the Twitters and the question and Q&A forums within the webinar. If you @ vBrownbag or hashtag vBrownbag, I'll be paying attention. Like I said previously, our guest this evening is Mr. Bryan Krausen. He is at IT Diversified, and this is a really good website for all of your Amazon and other needs. My name is Chris Williams. I'm Mistwire. And Mr. Krausen, are you there?
Yes, I am here.
Awesome. Let me make you the presenter. Yes, I'm sure. And you have the helm, sir.
All right. You guys see my screen okay?
Not yet. Yeah, there we go. Now it's up.
Okay, wonderful. All right. So first of all, thank you for having me on tonight, and thank you guys for doing the kind of migrating over to the AWS side. I know just from the community and all that, it's become quite the popular topic here, and so I think it's kind of a timely series, for vBrownbag. So yeah, so for that, kind of get started here, as you said, I'm kind of doing Domain 2 tonight. So, come on, what's going on here? All right, there we go. All right, so I don't want to focus too much on this. Obviously, you can look at it afterwards. But kind of got started in AWS back in 2011. I say involuntarily. It was kind of the age-old. The developers took a credit card, swiped it, started putting out some websites out there, and eventually there's enough out there to warrant the security team to force the infrastructure team to take that over. So kind of got started back in 2011, been kind of on and off since then, and the last year or so kind of putting a lot more focus on it. Technical architect at AHEAD, and also kind of a member of one of the Amazon Workspaces team, virtual teams here at AHEAD, so kind of focusing on that solution. Kind of the bottom, I have passed all 3 the associate level certs earlier this year. Yeah, thank you for that. And I'm currently studying for the cert, Certified Solutions Architect Pro. So I scheduled that just I think 2 nights ago. So I'm going to try to take that at a reInvent when I go out there in November. So that should be interesting. So kind of a recap, kind of where we're at. So this is kind of the blueprint. Obviously the check marks, the ones of the vBrownbags that we've already done. Next week, one of my colleagues, Zach, is going to be working on the troubleshooting one. And, obviously we're at Domain 2 right in the middle there. So luckily, kind of left as a breakout of, what each part represents on the exam. So luckily for you guys, if I'm terrible tonight, I'm only taking up 10% of what you have to know for the exam. So, so here's kind of a quick breakout of the blueprint Domain 2 here. It's really about implementation and deployment, which I find kind of interesting because this is more of a solutions architect exam, and so it doesn't necessarily focus a lot on actually implementation, but some of the content we'll go over tonight is still, pretty critical to know for the exam. So, so kind of kick off here. One of the first subjects, configure an Amazon machine image, or what a lot of people will call just an AMI here. So what is an AMI really? It's what you VMware guys would call a template. So really an AMI, contains template for the root volume like it would on a VMware side, obviously. That can contain, your operating system, your application settings, whatever you deem necessary for a kind of a gold image, if you will. It also includes the launch permissions. So what I mean by that is, are you the only one who can see the AMI and actually launch from it, or are you going to make it public, so anybody in the world can do that, or you can actually share it with individual accounts, like specific accounts, either within your organization or friends or family or, whatever, what have you. And then last is, the block device mapping, basically the drive, right, that the OS is going to be deployed upon for the instance. So again, as I said, AMI is really a template to create instances. That's in EC2. You also need an AMI to point to an AMI for CloudFormation and OpsWorks as well, from an automation standpoint. So, and the ones in red, by the way, are kind of, information I deemed, important for the exam, by the way. I know some of the other presenters did that, so kind of follow that here. But, AMIs are regional, so keep that in mind. So, if you deploy your own AMI in, say, Northern Virginia, it's only going to be available in Northern Virginia unless you copy it to a separate region, and we'll talk about that in a little bit. And each AMI actually has a unique ID to it. So, again, when you specify an AMI to launch, you can choose from either community AMI, which is a publicly shared template, basically, a private AMI, which is your own, right? You're the only ones who can see it. And then you can also choose an AMI from the AWS Marketplace. So when you talk about things like this, you're looking at, F5 load balancers or Cisco firewalls, or any of those kind of third-party products that you would pay for, licensing either from your vendor, or you kind of pay as you go, by the hour there. So, and the one thing I do like to mention here is because AMIs are regional and each AMI has a unique ID, the IDs are also region-specific. So, for example, the Amazon Linux AMI in Northern Virginia, has an ID of, 6869805, but the same exact template, in Oregon has a different, AMI. So that's important when you're working with, platforms such as like VRA, when you're trying to, automate the deployment of instances, from either an on-prem solution or something like that. You have to be sure that you're, if you want to deploy to Northern Virginia, you need to use the AMI ID for the template in Northern Virginia. So just kind of keep that in mind. So kind of put down there, they're like the same, but they're kind of different here. So keep on with AMI here. So you can really select it based upon, the region again, obviously the operating system was Windows, Linux, what have you. Obviously architecture, 32, 64-bit, launch permissions and storage, and on the storage piece, I kind of thought it was important just to call this out. I know this isn't necessarily a storage conversation, but kind of blends in with the machine images here, the differences between instant storage and EVS back storage. So just something to keep in mind that instant storage is ephemeral storage, so it does not persist beyond that instance. So if you shut that instance down, that data is gone forever. So don't put anything important on there. A couple other stipulations with instant storage that I thought were important. So you can only attach instant storage during the launch of an instance. You cannot add instant storage after you've launched a virtual machine, or sorry, this is my VMware terms, after an instance. Because of that, you can't stop the instance. So you can only reboot it or terminate. Otherwise, you try to stop it, you would obviously lose everything on the drive. So you can only reboot or terminate an instance running on instant storage. And then, because you can't stop it, that means you can't change instance attributes. So you can't stop it and say, hey, I want my T2 micro to be a T2 large anymore, because obviously if you stop it, you're going to lose all the data. So just something to remember there. And if the underlying host fails, you will lose your data. Everything kind of goes back to being ephemeral storage at that point. Where, complete opposite, EVS back storage is persistent. Total opposite of really instant storage. So you can add volumes after launch. You can stop instances that are utilizing EVS back storage, typically faster. But something to remember is by default, and this could be an exam question, by default, the root volume is deleted when the instance is terminated, and that is an option that you change when you're launching the instance. Now that is only stands for the root volume. If you add additional volumes to an instance, by default, those are not deleted. But by default, the root volume is definitely deleted upon termination. So, so how do you configure, you know, an AMI? Now that we know what it is, so you kind of start with a base AMI. So you kind of go out to Amazon and say, hey, you know, we're a Windows shop. I'm going to, you know, spin up a Windows Server 2012 server, and then we're going to customize it from there. You know, very similar to what you would do from an on-prem solution, you know, like VMware, where you're creating a template that you're going to create, you know, multiple servers from that template. So, you know, from the base AMI, you launch an instance just like you would on the VMware side, and then, you know, you put your applications, you know, do your settings, copy any kind of data that you need over there, whether that's scripts or, you know, install, you know, PuTTY or Office or, you know, whatever you're going to do to this image. So at that point, you want to stop the image, right? Because you want to make sure that you're going to get an application crash consistent image here. So you want to kind of stop it at hammer time. And then
I see what
from there, once it's, yeah, anytime I see stop, I always think hammer time. So, so once you stop it, then you can right click it, click the image, you know, from actions and say create an image. And that'll create, you know, your image for you. So from there, the image, you know, is available for you, you know, to launch future instances. And then from there, you know, you can obviously launch as many instances as you want. And then just keep in mind that wherever you create that image, that's where you're going to, by default, launch images into. Now, again, you can click that image and you can copy it to another region if you do need it in a separate region. So, so real quick, just some nomenclature here versus AWS versus VMware. I thought that was kind of good to put it here. So, you know, an instance is kind of, you know, from a VMware perspective, is equivalent to a virtual machine. AMI is a template. Instance storage is really like a non-persistent disk. EBS back storage is persistent disk. Snapshot is a snapshot. And then launch instance is really the same as, you know, kind of a deploy from template there. So from that, I'm going to quickly into AWS and kind of show you how to do it here. So from the console, you know, we'll go into EC2 here. This is a shared ahead account. There is a bunch of stuff out here, but so to save a little time, you know, kind of created a deployed a Windows 2012 server here. You can kind of see that T2 micro. It's already got a private IP and public IP. You know, so for this, we can launch into it. I think hopefully this works, and I've got to. Sorry, I forgot to get the Windows password and copy it. My fault. This is how you get the Windows password, by the way, decrypt. All right. Cool. So now we are in that T2 micro instance here. And for the fun of it, you know, just for demonstration purposes, you know, I've got like Notepad++ or whatever. So, you know, we can install this on our instance for the fun of it. Whenever finished. Okay, so now we have, you know, some kind of, you know, application installed on our server. So from here, we can shut it down. You can do it from here. You can do it from the console. We'll kind of wait for that to shut down. It shouldn't take but a second. Find it. So it's stopping here. If I'm going too fast here, let me know. So, while it's stopping, we can go to image. Let's pretend it stopped. So you can go to image here to create your template. You know, after you've created, you know, done all your settings and you copy all your data or whatever. So just basically you go up here and create image. Pops up. You want to call it, you know, call it whatever you want. vBrownbag, demo, and image description, awesomeness. And you can say, So if it is running, you can tell, say, don't reboot my instance. When you're taking a snapshot, obviously it's better. If you let it reboot it itself, shut it down, take the snapshot. And here you can actually resize the drive too. So you say, hey, I deployed it with 10 gig. Obviously, that's not enough for Windows moving forward or any given purpose. So you can say, hey, I want to do 40 or something like that. You can also change it its volume type as well. So I'll say, yeah, I want to create the image. So image request receive. And so from here, we'll look at the AMIs on your left here. And you can say it's creating it from that image or that instance that we did. So I did create one before, just to save time. It took like 5 or 10 minutes. So I created one earlier. So from here, you can see that you can actually launch it right from here. You can launch, and it goes right into the launch instance wizard here with the we're already past the choose AMI, right? So, or you can actually grab the AMI ID right here if you want. So that's your unique ID for that particular AMI. And you can kind of go back to the the dashboard, or here you can launch instance. You can go to either my AMIs, and you can see it right here. Here's the one I just created. I don't know if it's done yet or not, and you can select it from here. You can also just search. So if you have a bunch of them, you can search for the AMI or the name or whatever. So obviously select that, you're back to exactly where we were here. And you continue down the wizard and launch future instances from that individual snapshot there, or AMI. So that's about it on that. Again, AMIs in here, you can see whether they're private or public. So all these are private. Obviously, if we want to make them public, you can go in here. You can modify the image permissions. You can say public, and also you can add particular account numbers. So Chris had an account number. That was his account number. We say add permission, and now Chris would be able to launch that same AMI into his account.
Sweet.
So kind of cool there. Yeah, kind of sharing templates. The one thing to know though on the AMI, so when you do go to the regular launch here, right? So you have yours. So these are your private. You have the marketplace, what I talked about before. So you got Barracuda, you got F5, and all this kind of stuff. There's tons of stuff out here. And then community AMIs are really the public ones, right? Just something to keep in mind here is Amazon does not, they don't necessarily scan these for security. They don't manage these at all. So it's entirely possible if I pick this guy right here, it could have some kind of malware or keylogger or something like that on there. So for me personally, I would never select a community AMI unless I know exactly what it is or if it was shared, by a friend or colleague or something like that. But again, typical kind of thing. You can limit it down to Amazon Linux and Windows and your architecture and all that kind of stuff here as well. So it's just something kind of to keep in mind there. So let's go back to here. That's about it on the AMI stuff. If you have any other questions, let me know. I'll kind of stop there, see if there's any questions on the board there.
A couple. How is licensing handled with the community AMIs? Looks like there were some Windows servers there.
Yeah, as far as I know, everything from community it's not a bring your own license. From my understanding, you're still paying for that Microsoft license. Now there are options to bring your own license if you have like an ELA or something like that, and so your cost per hour is cheaper since you're not paying for that Microsoft license.
But for the community versions, that's the one you can't supply that. You can only do that for the ones that you're spinning up fresh from the non-community templates.
Honestly, I don't know. I can definitely follow up on that. I'm pretty sure it follows the same, as if you were to choose, one out of the quick start, because all the quick start ones are basically community AMIs. They're just ones that are managed by Amazon.
Gotcha. Okay, cool. Let me double check. Nope, that was it. We're good for questions.
Okay, cool. So kind of the next part was really, operating in service management, utilizing basically hybrid IT architecture. So I thought this was kind of interesting. People always talk about, how they think they're going to lose their job to cloud, and if their company, decides to go full AWS, then they're not going to be employed anymore. And I think that's totally false, right? I mean, skill sets that you're learning, with your on-prem data center, are absolutely relevant, in a cloud world. Networking is networking, right? And regardless if it's on-prem or if it's in AWS, right? A subnet and a /24 means the exact same thing in both sides, right? You still need, your relevant Windows skills. Your storage skills may not be, as detailed. You're not provisioning LUNs and NFS and stuff like that, but in my opinion, all those skill sets are totally relevant moving to a cloud world. So you just may need to really expand and kind of rethink your approach from, a traditional deployment to something that you're going to do, in the cloud. So really kind of where do you start? I mean, it's kind of overwhelming if you look at, all the options and stuff like that. So a lot of people, like, hey, I want to move forward this cloud thing. I don't know really how to kind of get started. 13 regions, 35 AZs, 58 edge locations, and all these different, microservices and, interactions, whether that's SDKs or command line or, in the GUI or whatever. So, we definitely a world of possibilities there, right? And you definitely understand it can be overwhelming if you're not familiar with Amazon kind of getting started. So, from what we've seen from a customer side, a lot of business units and application teams are already using it, right? And the infrastructure teams may not even know, and organizations may have dozens of, active billing accounts, and they don't even know, shadow IT here. So, it's kind of really a result of how easy it is to build on Amazon, where, a lot of development staff really, they don't want to wait, on the traditional infrastructure policies and procedures. They just, they kind of want it now. So, what we, mean by hybrid is kind of get started here with kind of build a critical foundation here. So, really set your network up. Obviously it's going to be kind of the same as the on-prem, right? So you got to kind of get the plumbing phase in place first before you can really start doing anything else. So, there are obviously a lot of other options, or a lot of options that we've talked about already. So, the VPC, you can extend that using VPN. You can do direct connect. And kind of once you do that, you want to start, extending your directory services or any kind of identity management, into the cloud as well. Obviously, you want to be able to use IAM. You set up, all your accounts, whether that's, you're using your Active Directory accounts, so you're federating from your AD and utilizing that to log into AWS. And then, billing and management, how are you going to do that? So it's really a process to kind of, from an enterprise standpoint, to properly kind of get that down. So, and then, definitely implement a centralized managing billing service. So you don't have, accounts that are all getting billed to separate, company Amexes, and you don't really know what's going on, in the environment as a whole. So if you kind of do manage billing, consolidated billing, and utilize tags properly, so you know exactly where your cost and spend is going across the board. And then from there, start trying to utilize, some of the automation tools out there, CloudFormation, stuff like that for your standard VM. If you have a particular application, that's pretty standard, it's a 3-tier with a database server or whatever. Utilize CloudFormation rather than doing it all that manually. That's what the cloud is for, right? Or its purpose. Public cloud is best to automate everything. So you're removing a lot of the manual stuff. And that's how you're kind of getting the go-to-market speed and stuff like that. And then from there, kind of extend your on-premises automation, configuration management, and controls out to AWS as well, so you can manage everything properly. And then from there, obviously you want to do a test run, kind of find some low-hanging fruit, applications that you can kind of test with. utilize those to, look at the performance, look at, how you can improve, deployment from that versus, doing it on-prem. And then, obviously you want to, extend all the benefits of the data center, into AWS. So from what I've seen, typically there's, you get this group of, kind of your, your settlers, if you will, that are your traditional IT guys. You get a couple of guys over here that are, really your pioneers. These are the guys that kind of want to move forward, utilize the emerging technologies. And, so a lot of your other guys, after when you start doing a lot of this stuff, I mean, you definitely will pull in some guys, from that other team. Now, you will have guys like this guy that don't want to give up their stand and they don't want to give up their Cisco CLI and stuff like that. But for the most part, you'll find that a lot of people, as they start using it, they'll definitely want to move over to the cloud team and start utilizing a lot more. This is what I've seen in the past. So really to kind of summarize that, again, work on the plumbing phase first. Obviously that's important. If you don't set a good groundwork, then you're going to fail. And then start playing around with more of the emerging technologies, continuous integration, continuous deployment, whether it's DevOps. Start looking into cloud operations. How does it tie into on-prem? Obviously try to use a lot more of the public cloud services to make your job easier, right? I mean, rather than deploy like RabbitMQ or any kind of messaging services, start utilizing those microservices like SQS and SES and all that, just to make your life easier and really try to decouple the application from the individual instances to make your automation piece easier as well. Then obviously use additional IaaS and software-defined networking here. So that's kind of the hybrid cloud kind of stuff. Any questions on that piece?
No, that's good.
All right. So really the next topic here, looking at time here. All right, cool. Configure compliance in private public cloud. And on this one, I didn't want to get too deep because I know Anthony did a whole security module last week. So I just really just want to touch on a couple things I thought were important here. So obviously you want to reduce manual interactions if possible. The more human interactions you have, the more likelihood that you're going to have missteps. Whether that's a misconfigured security group, you actually left it open to the world or something like that. So if you're using automation to deploy your infrastructure, then use automation to secure your infrastructure as well where possible. So obviously you want to protect like any other workloads, firewall permissions, stop unnecessary services, stuff like that. And it goes back to the whole cattle versus pets thing, right? I mean, if it's pets, and it's definitely you have to spend a lot more time on it. You're put permanent solutions around like antivirus and stuff that you did for traditional workloads, where kind of your elastic servers may still require those advanced security services, but you can maybe go a different way, with those, utilizing some of the services built into AWS. Again, as always, practice of least privilege here, especially in IAM. Avoid using a root account. So, you definitely want to create a root account, set up MFA on that, and then start creating IAM users for individuals. And then obviously only give those individuals, enough access to do what they need to do. Utilizing IAM roles, versus saving credentials within an instance, are a lot better. That way, if the instance is ever compromised, your credentials are not, held within that instance. And then, utilize the functions within AWS, especially security groups. Put network ACLs on there. It gets a little messier using those. I'd rather use security groups, but ACLs from like an SC3 standpoint. And obviously if you're using a domain, you're going to go back to AD permissions, NTFS permissions, whatever you've used in the past, it's still going to work in the cloud. Especially from an automated perspective using, all your tools. use the AWS tool. So make sure you use MFA for all your users, and more importantly, utilize like CloudTrail and config to monitor what's actually going on across the environment. Use config to see who made changes and what changes they made, right? And use CloudTrail to enable that across every single region. In AWS, in my opinion, just because you're utilizing Northern Virginia, it doesn't mean that you don't need to enable CloudTrail in Oregon, because what happens if your account gets compromised and they start deploying stuff in Oregon? If you're not logging at the CloudTrail, you're not going to have any logs on that. So definitely enable that across the board, in my opinion. And then, again, start using the AWS services rather than host them, on EC2 instances. SNTP, use SES, MSNQ, use SQS, stuff like that. From an S3 perspective, use versioning. Make sure that, if something gets inadvertently changed, you have the ability to revert back to a previous version and restore that data. And then make sure you're logging your requests and everything to a bucket in S3. Make sure that you're covered from that perspective. And then, obviously encrypt all the things. So use certificate manager. There you can do key management. You can do create SSL keys. You can do certificates and all that. Make sure you encrypt your EC2 volumes and S3 data and anything else that you're utilizing. So there's kind of saying it on AWS. Really AWS is responsible for the security of the cloud, and really the customer is responsible for security for what's in the cloud. So just kind of keep that in mind moving forward there. So configure IAM policies is really kind of the last piece. This is kind of going pretty quickly.
No, this is great.
So, yeah. Any questions on the security piece or anything like that?
Let me double check. No questions there. Nope. We are good for questions, sir.
Okay, cool. All right. So really, the last piece of the this domain, like I said, it's kind of a shorter one in my opinion, because this is a an architect test, and this is really more about implementation. So it's really configure IAM policies and best practices. Apparently I spelled policies wrong. That's awesome. So, so really, a policy is a document that states normal permissions, across the board for AWS. So, it's something to think about. Just because you have a user account in AWS, doesn't necessarily mean you can do anything in there, right? I mean, same thing for like Active Directory. You mean I can create a user in AD, but if I don't have any permissions. Obviously you can't do anything. You can't access, shared file systems. You can't log into servers. You can't log into, desktops or whatever. So same thing here. IAM policies are written in JSON. So, really a basic policy is comprised of actions. What are you going to allow? What resources are you going to apply to? What are you going to allow the action on? And the effect, right? So that's obviously, allow or deny. Just something to keep in mind with IAM policies and IAM in general. Everything by default is implicitly denied, right? So if you don't have the allow, it's going to be automatically denied, kind of like a firewall top down, right? If it's not explicitly allowed, that last policy is going to be a deny all here. So just something to remember there. So quick example of IAM policies. This one just allows you to list the contents in a very specific bucket here within S3. So kind of next step. How are policies made? This is kind of a dumb slide I want. So this is not how policies are made.
Nice.
So you kind of go to. It's pretty easy to do, really. I mean, there's 3 ways to do to create a policy. You can utilize the AWS policy generator. Just more of a kind of a GUI, like wizard type, walk you through how to create it. You can select one of the AWS managed policies. So that's a default one on the right. Allow everything allow the user to do everything on S3. And the cool thing is you can take those AWS managed policies and then you can customize them to your needs, right? So I'll say allow S3, and I can put like the specific resource on there if I want. So you don't have to necessarily start from scratch if you don't want. And then the last one I put, you got to bring your own JSON. So you can say I want to do it, build it from scratch basically. It just comes up with kind of like a notepad where you can just kind of start, typing out JSON and write your own here. So how to do it, from the AWS console, you go to IAM, policies, and you create new here. So we'll kind of go through that real quick. So we'll walk through the console. So under identity access management, so on the left here we'll have policies, and then here you can create a policy, right? So you can say copy a managed policy, go through the policy generator, create your own policy. So for example, we create your own, basically policy name, description, and just gives you kind of like a blank notepad to start typing here. Policy generator, select next. You got it, obviously there's your effect, there's a service, so you can select from, whatever you want. So say we're going to do workspaces. We're going to say I'm going to allow this guy to create a workspace and start a workspace, right? And then you can, add a statement, next, and then so you can actually see the JSON here. Create it whatever you want, call it whatever you want, workspaces, permissions, whatever you want to call it. You can validate it here, so you can't spaces. Validate it. Okay, it'll tell you whether it's valid or not, whether the JSON is correct here. Then you just create the policy. So now you can assign these policies to users. You can assign them to buckets or anything across AWS. And the last thing is here's all the managed policies. You'll have your own here too, the ones that I created before. But here's administrator access for everything. So this is basically the equivalent of a allow every allow star basically. So if you assign this policy to a new user, they have administrative access to anything, everything AWS, anything in in here. So they can do basically anything across the board here. So you want to be careful with that, obviously. But if you've got you're trying to practice least privilege, you've got a guy or you've got a role really or an account that you want to use for API access. I only want to allow this guy to spin up instances and he's never going to delete them or something like that. So you can kind of go through create your API policy, if you will, and then assign that to the user. And so now that user only has enough permissions to perform the job he needs to perform and nothing more than that. So something to keep in mind there.
Two quick questions.
Yeah.
If you use the generator to build a policy, can you hand edit it later?
Yeah, you can.
Okay. And the second question, I'm sorry, go ahead.
Let's say you can do it like right here. So you can, when you go and say for example, next, so you can actually go through and start typing here. So you can edit it before you ever save here. So you can always, say, oh, I meant to do deny, whatever. You can edit it before you validate it or create the policy.
Gotcha. Okay. And the other question was, do you find that the out-of-the-box policies are sufficient, or do you spend a lot of time creating custom policies?
It's really up to the use case, right? There are a ton of out-of-the-box ones. You look at there's 218 here, but
right.
And remember these are kind of generic, right? So this is saying allow full access to SES, and then you can apply this to a particular user, account, or whatever. But if you even want to go deeper than that, you say I want to allow SES, but then you actually want to say I only want SES is probably a bad example, but like S3, full access. You only want to say I want to allow everything in my bucket Gotcha. My bucket number one. You have to copy this one first, but you could say resource only my bucket number one kind of deal. Then you can do that as well. So it's really, it's per use case. You can, just use the out-of-the-box ones, but remember they're kind of generic, and they don't go down to your particular bucket, right? So if you want to say, only allow permission to only delete, out of bucket, 1, 2, 3, 4, then you'd have to create, take this policy, modify it to say only bucket 1, 2, 3, 4, create that, and then assign that to the user.
Cool. Thank you.
So you can definitely get away by using the default one, so if you want.
Okay. Was it for questions?
All right. Cool. So I go back into this here. So really, I think the last thing really is kind of best practices, and really just kind of it goes back to a lot of the stuff we kind of talked about already, right? Try to assign policies to groups of objects versus individual objects. It's kind of the old adage in AD, right? You're assigning NTFS permissions. Utilize groups versus adding individuals there, right? It's easier to set up in the first place, and it's easier to manage moving forward. That way you don't have to remove, individual objects or add it, individual places. You add a user to a group or something like that, and they've got the proper permission. Again, practice least privilege, and it kind of goes back to the last question, right? Just because, Bob needs access to bucket A, because he's in accounting and he deletes files, after he's imported them, do we really need to give him full-blown access to everything in S3? Should we create an IAM policy and just restrict him to only delete, right? I mean, it's not necessarily about protecting your data, but what happens if he accidentally, if he was creating stuff and he accidentally deleted something, and he wasn't supposed to. So that's to kind of help prevent, outages and problems and data corruption and all that kind of stuff moving forward. As I said before, use implicit versus explicit. So by default, everything's deny. So only allow the things that you really need to allow, and only use explicit denies when you really need to. And then you can also use like policy conditions, right? That's another piece of an IAM policy, a policy that you can utilize to really limit access or restrict, for like elevated permissions. So say for example you've got a new junior admin on the team, and he's pretty new with AWS, but you're going to say, hey, he's going to be the guy that cleans up, instances when, an automation script doesn't do it or something like that. You want to limit access to, any account to be able to delete your data, right? So you can put a condition in the IAM policy to say, make sure that the user logged in that has permission, make sure he logged in using two-factor authentication, so this account, wasn't compromised or something like that. And then you can also do things like limit access from IP ranges. So, if you only allow, access to Amazon, from your corporate office or something like that, limit it from those IP addresses. And you can do a lot of things, date, time, and stuff like that. So, only allow the deletion of an object from, 8 p.m. to 10 p.m. or something like that, because it's when, we drop off traffic and auto-scaling starts deleting things, or, whatever. So you can kind of use that to kind of really limit access as well. So I think that's really about it. I mean, like I said, I feel like it's a kind of a smaller domain. It's only really 10% of the whole blueprint here, but some of the links I thought were important. Amazon recommends using Syspress if you're doing a Windows AMI. It's very similar to what if you were doing it on-prem, right? So there's kind of a link to walk you through that. There's more of the policy elements. So what are all the elements that you can utilize within an IAM policy, and how to use them, like the condition that I was just talking about, stuff like that. There's some IAM limitations, including like the character limit for IAM policies. I mean, it's pretty high. It's like, 2,000, 4,000, stuff like that, characters within an IAM, and they don't count white space on that either. So, I think back to kind of more of a generalization, AWS certification guide that we talked about, the blueprint, and then just a link to kind of like our cloud delivery platform that we have here at Ahead. So really that's about it. Is there any other questions? Kind of hit the 45-minute mark here. I figured it'd be a little shorter one than.
No, you timed it perfectly, sir. Let me double check the Twitters. No, we're good there, and we are good locally as well. Fantastic timing. 45 minutes on the nose.
Awesome. Sweet. Good deal.
Cool. Okay. Well, thanks very much for covering Domain 2 with us. Definitely appreciate it. And I'll hit you up afterwards to talk about studying for the SA Pro Cert.
Okay. Yeah, definitely. Thank you for having us on. Again, thank you guys for doing this series. It's been great so far. And I think it's going to help a lot of people that are studying for this associate level test.
Very cool. Awesome. And I'm stopping recording.